The recent developments surrounding NASA's massive moon rocket have ignited one of the most intense debates in modern space exploration. This rocket, officially called the Space Launch System, was designed to be the backbone of humanity's return to the moon under the Artemis program. It represents decades of planning, engineering, and political commitment, and it was envisioned as the most powerful rocket ever built for human exploration. Standing taller than the Statue of Liberty and capable of producing more thrust than the legendary Saturn V, the rocket symbolizes NASA's determination to lead humanity into a new era of deep space travel. But despite its impressive size and power, growing concerns have begun to emerge about its true effectiveness, long-term sustainability, and whether it can realistically meet the demands of the future. One of the central issues lies in the rocket's overall cost. The total investment has reached an estimated $23.8 billion, making it one of the most expensive space launch systems ever developed. This enormous cost reflects not only the complexity of the rocket itself but also the years of delays, redesigns, and testing required to bring it to life. Each component had to be carefully engineered to handle extreme forces, temperatures, and vibrations. However, the high cost has also drawn criticism from analysts who question whether such an expensive system can be used frequently enough to justify its price. Space exploration has always been expensive, but in today's rapidly changing technological environment, cost efficiency has become more important than ever. Another major concern involves the rocket's expendable design. Unlike newer systems that aim to reuse their components, this rocket discards its core stage and boosters after each launch. This means that every mission requires the construction of entirely new hardware, dramatically increasing the cost of every flight. In the past, this approach was standard, and it helped achieve historic milestones like the Apollo moon landings. But today, the industry is evolving. Reusability is becoming the key to making space travel more sustainable and accessible. The fact that NASA's rocket cannot be reused in the same way has led some observers to question whether its design reflects the future of spaceflight or the legacy of its past. The slow pace of development has also contributed to growing frustration. The rocket was first announced more than a decade ago, and its timeline has shifted repeatedly due to technical challenges and funding issues. Each delay has pushed back the schedule for returning astronauts to the moon, extending the gap between ambition and reality. These delays are not unusual in complex engineering projects, but they highlight just how difficult it is to build a system capable of safely carrying humans beyond Earth orbit. Every delay also increases the overall cost, placing additional pressure on the program to prove its value. Despite these challenges, the rocket has achieved important milestones. Its first launch demonstrated that the core concept works and that it can successfully send spacecraft toward the moon. This was a historic moment, proving that NASA still has the capability to build and operate extremely powerful launch systems. The launch inspired millions of people around the world and reminded humanity of its ability to achieve extraordinary things. But even as celebrations took place, deeper questions remained about how often the rocket could realistically fly and whether it could support a sustained human presence on the moon. Another layer of complexity comes from the expectations placed on the program. This rocket is not just a piece of hardware, it represents national pride, scientific progress, and the hope of future exploration. It is intended to carry astronauts who will build lunar bases, conduct experiments, and prepare for missions to Mars. The success or failure of the rocket will influence the direction of space exploration for decades. This enormous responsibility adds pressure to every test, every launch, and every decision. At the same time, the global space environment is changing rapidly. New technologies are emerging, new companies are entering the field, and new ideas are reshaping what is possible. The definition of success is evolving. It is no longer enough to build the most powerful rocket, it must also be efficient, sustainable, and capable of supporting frequent missions. This shift has created a new standard against which all launch systems are judged. Engineers inside NASA understand these challenges better than anyone. They have worked tirelessly to ensure that the rocket meets strict safety and performance requirements. Human spaceflight leaves no room for error. Every system must function perfectly to protect the lives of astronauts. This commitment to safety is one reason why development has taken so long and why costs have been so high. Safety cannot be rushed, and reliability cannot be compromised. There is also the reality that this rocket was designed during a different era, when the space industry looked very different than it does today. At the time, the focus was on building a powerful, reliable system using proven technology. The goal was to ensure mission success, even if it meant higher costs. But as technology has advanced, new approaches have begun to challenge those assumptions. Public perception has also played a role in shaping the conversation. Many people see the rocket as a symbol of hope and progress, while others see it as an example of how difficult and expensive space exploration can be. Both perspectives are valid. The rocket represents both the incredible ambition of humanity and the immense challenges that come with turning that ambition into reality. Ultimately, the story of this moon rocket is still being written. It has already achieved historic milestones, but its long-term legacy remains uncertain. It could become the foundation for a permanent human presence beyond Earth, or it could serve as a stepping stone that leads to even more advanced systems in the future. What is clear is that it represents a critical moment in the evolution of space exploration. This rocket stands at the intersection of past and future. It carries the legacy of the Apollo era while attempting to open the door to a new age of exploration. Its success will depend not only on its power but on its ability to adapt to a rapidly changing world. And as humanity prepares to return to the moon, this rocket will remain at the center of one of the most important journeys ever attempted. While NASA continues to develop and prepare its powerful moon rocket for future missions, a new and unexpected challenger has dramatically reshaped the conversation about the future of space travel. That challenger is SpaceX, a private space company that has approached rocket development in a completely different way. Instead of relying on traditional expendable systems, SpaceX has focused on building a fully reusable launch vehicle known as Starship. This single idea, reusability, has the potential to change everything. Rather than throwing away major parts of the rocket after each mission, Starship is designed to return safely to Earth, land vertically, and be prepared to fly again. This could reduce the cost of spaceflight dramatically and make frequent missions possible in a way that was never practical before. What makes this comparison so powerful is not just the technology, but the speed of progress. While NASA's system has taken many years and tens of billions of dollars to reach its current stage, Starship has moved forward through rapid testing, learning from failures, and making improvements at an incredible pace. Each launch provides valuable data, and each new version incorporates lessons learned from the last. This approach allows development to move faster, even when setbacks occur. Instead of waiting years between major tests, improvements can happen within months. This faster cycle of innovation has created the impression that spaceflight is entering a completely new era. Another key difference is the long-term vision behind the system. Starship was not designed for just one destination. It is intended to carry humans and cargo to the Moon, Mars, and possibly even farther. Its large size and cargo capacity could allow it to transport entire habitats, vehicles, and infrastructure needed to support human life on other worlds. This opens the possibility of building permanent settlements beyond Earth. The idea that one reusable rocket could support such ambitious goals has captured global attention and sparked both excitement and debate. This does not mean NASA's rocket has no role. In fact, NASA's system remains extremely powerful and capable. It was designed with safety and reliability as the highest priorities, especially for carrying astronauts. Its missions are carefully planned, and its engineering reflects decades of experience. NASA's rocket will still play a critical role in upcoming moon missions, including sending astronauts into lunar orbit. But the presence of Starship has introduced a new level of competition and expectation. Suddenly, the question is not just whether a rocket can reach the moon, but how efficiently and how often it can do so. This moment represents a major turning point in space exploration. For decades, government agencies led nearly every aspect of human spaceflight. Now, private companies are playing an increasingly important role. This shift is changing how missions are designed, funded, and executed. It is creating new opportunities, but it is also creating uncertainty. No one knows exactly how this competition will unfold, but it is already accelerating progress. In the end, the future may not belong to just one system, but to a combination of both. NASA's experience and stability, combined with the speed and innovation of private companies, could work together to achieve goals that neither could accomplish alone. The race to the moon is no longer just about national pride, it is about building the foundation for humanity's future beyond Earth. And whether NASA's giant rocket remains dominant or is eventually surpassed, it has already played a crucial role in pushing humanity closer to the stars.